Hello, everyone. We're going to talk about symmetry today. And we've heard of symmetry when we talk about geometry, but today we're going to talk about with algebra and looking at the graphs. So this is what we're going to do. We're going to talk about x and y axis symmetry, the origin, and determining if it's even, odd, or neither. Okay, so first of all, what am I talking about for symmetry? Well, if you have 2 points, 4, 2, and 4, negative 2, and 4, negative 2, we say that they reflect over the x-axis. And all points that reflect over the x-axis have the same x and opposite y's. So we could say that if you have a point xy on a graph and x negative y on a graph, then you have, I'm yawning, I can't believe that, I'm sorry. You have what we call x-axis symmetry. So let's take a look here. This graph, which is x equals y squared, is what we call x-axis symmetry, and you can tell. Now, unfortunately, with x-axis symmetry, these guys are not going to be functions. Why aren't they going to be functions? Because by definition, they will fail the vertical line test. Because when you plug in 4, sometimes you get 2, sometimes you get negative 2. So these aren't functions, they are relations, and they just have x-axis symmetry, and you could tell by looking at the graph. Okay, how about these next 2 points? What if you have 3, 4, and negative 3, 4? Well, let's see here. 3, 4 would be up here, negative 3, 4, which should be up here. Now we're talking about y-axis symmetry. Y-axis symmetry, reflect over the y-axis. And if xy is on a graph, then negative xy is on the graph. And these can be functions. And y-axis symmetry, they are functions. And they actually have a special name, which we'll talk about in a few minutes. And these are actually called even functions. So if you see here, all these points, xy, negative xy, 3, 4, negative 3, 4, 2, negative 1, negative 2, negative 1. Okay, so they have y-axis symmetry, and we call them even. Now, what if both of them change? So they gave you some weirdo points here. But let's say it was just negative 3, 2.5, we'll say that instead. And then 3, negative 2.5, be down here. So they're opposite angled quadrants. We will say that they have origin symmetry. Also, we can call this 180 rotational symmetry. We'll take that. And that happens if both the x and the y are opposite of each other. So this particular graph has what we call origin symmetry, or 180 rotational, and xy is here and negative x, negative y is here. This point actually goes with this point. This point here at 2, a little bit more than 1, goes with negative 2, a little bit more than negative 1. So that is origin symmetry. And we call origin symmetry, we call these odd functions. This one is not technically an odd function because this does fail, but these can be functions. For example, if you have a graph that looks like this, they have the symmetry 180 rotational. This one is a function. So origin symmetry can be an odd function. Not all of them will be functions. So be a little bit careful with that. Okay, so we're going to test the symmetry. So how do you test the symmetry? Well, what would you have to do is you would have to check every single point on a graph. And you can't check all the points on a graph. So what we do is we use the equation to test all the points at once. So if it's x-axis symmetry, you're going to replace y with negative y. And if it's equal, if you get the same thing, then you have x-axis symmetry. Okay, for y-axis symmetry, replace the x with the negative x. And if you get x with negative x, and think about that here, if I had 2, it went with 3. If I had negative 2, it went with 3. So it doesn't matter if I plug in x or negative x, I will get the same y. So if you get the same thing, then you have y-axis symmetry. In a test origin symmetry, you have to replace both of them to see if you get the same thing, and then we call that origin symmetry. So let's see how this looks. We're going to test this for all the symmetry. Okay, so first let's do x-axis symmetry. Here's my problem, y equals x squared plus 2. So if I can get back to this after I do my plugging in, then it has that symmetry. So negative y equals x squared plus 2. Get y by itself, and I get y equals, you divide everything, it's negative x squared minus 2. Is that what I started with? No, this does not have x-axis symmetry. Okay, let's try y-axis symmetry. Y-axis symmetry tells you to plug in negative x for x. Clean that up. What is negative x times negative x? That's x squared plus 2. Is that what I started with? Yes, that is y-axis symmetric. What if you tried the origin? Does negative y equal negative x squared plus 2? Will that get me back here? That gives me negative y. That gets me the x squared plus 2, and the answer is no, because when I divide everything by negative 1, I get negative x squared minus 2, and that's not what I started with. So no origin symmetry. You can tell if you're doing this right by using your graphing calculator when you're done. X squared plus 2 is a graph like this, and you can tell the only type of symmetry it has is y-axis symmetry. Okay, even and odd functions, same type of thing. Even functions have y-axis symmetry. Odd functions have 180 rotational or origin. Okay, this is what's really important right here. Again, we'd have to check all the points. So what this is saying is, right here, plug in negative x, and you will get regular old f of x, the same thing you started with. Same original function. What this says for origin is if you plug in negative x, you don't get the same old original function. You get the opposite of original function, or change all the signs. Okay, so, and that's because, think about it, for the evens, remember this guy is an even one. If the point 2, 2 is on this graph, negative 2, when x is negative, you still get the same. Negative x still gets you the same. When it has 180 rotational, if I have 2, 2 here, if I have negative 2, now I get the opposite, which is negative 2. You can remember opposite, odd, if you want, okay? That will help you with some memorization. This is just telling you the exact same thing, and we're going to practice. Okay, so we're going to figure out if it's even, odd, or neither. Most graphs are actually neither. That's very common. They don't have to be even or odd. Most of them are neither y-axis symmetric or origin symmetric. Like think of this graph, it has no symmetry, it's over here. It doesn't have y-axis symmetry or 180 rotational. So a lot of times it's nothing. When you're checking, every time the step is the same, you just plug in negative x and you're going to see, do we get the same? Do we get the opposite? If it's the same, it's even. If it's opposite, it's odd. If you get something in between, it's neither. So let's try this. 5 times negative x to the 7th minus 6 times negative x to the 3rd minus 2 times negative x. Lots of negative x's here. You have to know some things about negatives. If you take negative 1 times itself 7 times, that's going to give me a negative 5x to the 7th. Minus 6. If you have a negative x 3 times, that's also a negative. So this is a negative x to the 3rd. Well, that's 2 negatives, guys. So it's negative 5x to the 7th plus 6x to the 3rd. And negative 2 times negative x is plus 2x. So I finished it up. Now we got to see. Is it the same? No. This is the opposite here. Is this an opposite? Yes. And is this an opposite? Yes. The entire thing is opposite. So this is what we call an odd function. If you were to graph it, it would have 180 rotational symmetry. That's what it looks like. And you can see if you flipped it upside down, it has 180 rotational symmetry. That's it for today. So you're going to plug in the negative x, and we're going to see if you get the same thing or something different or the complete opposite.